Hi dear students, welcome to our channel Exam Side Mathematics by Honey. In this video, we are discussing application of derivatives in that increasing decreasing questions exercise 6.2 NCERT solutions. It will help for the CBSE students. We already done 6.1 complete exercise application of derivatives in that rate of change or rate measure. All the questions are available, dear students. Once you go through the channel in the playlist, I already kept in that. Those who are watching first time, please like and share. Then it will be useful for me as well. Students, those who are studying 12th class. I hope all is well. Let us have a discussion. The questions here. Show that the function given by f of x equal to 3x plus 17 is increasing on R. So how to prove the given function is increasing? So based on the definition of increasing function, you have to consider one interval I. In that two numbers you have to select. Let x1 comma x2 belongs to interval means R here. You have to consider x1 comma x2 belongs to R, and f of x is given by 3x plus 17. So you have to prove the function is increasing means x1 is less than x2. That implies f of x1 is less than f of x2. If you prove that, this is the definition of increasing function, dear students. So x1 is less than x2. Suppose if it is x1 is less than x2 in the interval R, that implies here x coefficient is what? 3x according to the given function. So I want to multiply 3 with this 2. So 3x1 is less than 3x2. Multiplying on both sides by, someone is making comments. Thank you for joining in the sessions. Multiplying on both sides by 3. Why 3 only? Means here x coefficient is 3. That is the reason, dear students. Next here 3x plus 17 is there. No, you need to add 17 to this. 3x1 plus 17 is less than 3x2 plus 17. So f of x equal to 3x plus 17. So 3x1 plus 17. F of x1 is less than, this is f of x2. So therefore x1 is less than x2, that implies f of x1 is less than f of x2. That implies that f of x is increasing. Exactly, we can say that means strictly increasing, dear students. You remember, f of x is strictly increasing. They did not mention on real numbers or whatever it is given. Hence prove. That's all. How to prove this one? Show that the exponential function, even exponential function is also an increasing function. Show that the function f of x equal to e power 2x is increasing on R. Here also let x1 comma x2 belongs to R, and the function f of x equal to e power 2x. Now consider x1 is less than x2. x1 is less than x2. That implies here x coefficient is 2 is there, no, but of course it is in the power, but whose multiply is what? 2. So 2x1 is less than 2x2. So 2x1 is less than 2x2. We can powerize 2. So e power 2x1 is less than e power 2x2. Sir, how can we know this is whenever 2x1 is less than 2x2, e power 2x1 is less than e power 2x2, how can we say here e is constant, maybe a constant, but e value lies between 2 and 3. And example, if we say 1 is less than 2, e power 1 is less than e power 2, obviously no, e is less than e square, am I right or not? Absolutely. That is the reason e power 2x1 is less than e power 2x2. E power 2x1 means it is equal to f of x. 1 is less than f of x2. So therefore, x1 is less than x2, that implies f of x1 is less than f of x2. That implies that f of x is strictly increasing. F of x is strictly increasing. Strictly increasing. On R. Whenever it is strictly increasing on R, they are asking to prove that so, no? Hence prove the result. Yeah, we'll move to another question. Question number 3. Show that the function f of x, show that the function f of x is equal to sin x is, in that question number 1, increasing in open interval of 0 comma pi by 2. Second one, decreasing in open interval of pi by 2 comma pi. Third one, neither increasing nor decreasing. In open interval of 0 comma pi. So this is the question number 3, dear students. Before going to start this problem, the function is increasing, the function is decreasing by using derivatives. How to do that? F of x be a function, f of x is increasing, f of x is increasing, then f dash of x is greater than 0. Whenever f of x is increasing, f dash of x is greater than 0. You keep in mind these, it's a very important concept. Next, f of x is in particular interval, whatever it is provided. F of x is decreasing. Then f dash of x is less than 0. F dash of x is less than 0. Okay. After that, suppose f dash of x is not greater than 0, f dash of x is not less than 0, that time we can say that the function is neither increasing nor decreasing. We can say, dear students, see the time you can take the example. Show that the function f of x equal to sin x is increasing in this interval, decreasing in this interval, neither increasing nor decreasing in open interval of 0 comma pi. How to prove that? So f of x equal to sin x, differentiate with respect to x. F dash of x is equal to sin x derivative is cos x. F dash of x equal to cos x. Okay. Now they are asking to find increasing in this. F dash of x is cos x. What is the cos x curve? So this is the curve of cos x. Cos x not passing through the origin, dear students. We observe that cos x is greater than 0 where it comes. Cos x is greater than f of x. Now f dash of x is greater than 0 where it will be greater than 0. In 0 to 1. 0 to 1 it comes. 0 to pi by 2 we need to. 0 to pi by 2. This is the cos x curve, dear students. From 0 to pi by 2. So this value is minus pi by 2, 0. X value cos 0 is 1. Cos pi by 4, cos. F dash of x is equal to cos x is greater than 0. That implies f of x is increasing. F of x is increasing. 1 minute distance. Cos x in which quadrants? Cos x greater than 0 means 0 to pi by 2. 0 to pi by 2 where it comes? 0 to pi by 2 means first quadrant. F dash of x equal to greater than 0. Cos x positive where it will be? Generally cos x positive in first and fourth quadrant. Fourth quadrant means down it comes. No, so only first quadrant. F of x is increasing in open interval of 0 comma pi by 2. Similarly, f dash of x is equal to cos x is less than 0. That implies f of x is decreasing. In pi by 2 to pi. That means from here to here. Second quadrant. In second quadrant less than only cos x. So cos x is less than 0 in pi by 2 to pi. It belongs to second quadrant, dear students. 0 to pi by 2 is first quadrant. So in second quadrant, f of x is decreasing. They are asking to prove. And neither increasing nor decreasing. 0 and pi, in between 0 and pi, any value if you take, f dash of x is equal to 0. That implies cos x when it is equal to 0, x is equal to pi by 2. So at x is equal to pi by 2, f of x is neither increasing nor decreasing in open 0 comma pi. Even 0 comma pi means x equal to pi by 2 have taken. This is the way you can prove the given result, dear students. If you want clarity on this cos x greater than 0, that means x belongs to 0 to pi by 2. In between 0 to pi by 2, cos x is greater than 0. That is the meaning. Even here also, I will give clarity. F of x is decreasing in this interval means x belongs to compulsory pi by 2 to pi in this interval. Cos x value negative. If you want to take 120 degrees, if you take cos 120 is minus 1 by 2. Minus 1 by 2 less than 0 only now. Here 0 to pi by 2. Pi by 4 you take it. Cos pi by 4 1 by root 2. It is greater than 0. So in between these two, the value of x is in between. X belongs to 0 to pi by 2. The function is greater than 0. X belongs to pi by 2 to pi. The function is negative. That's why it is decreasing. It is increasing. In between 0 to, that means x is equal to, that means f of x is neither increasing nor decreasing. The value of x in between 0 to pi, 0 to pi. If you take cos pi by 4, 1 by root 2. Next is sin pi by 4, 1 by root 2. Both are same. Same values means how can we get? So x belongs to 0. X equal to pi by 2 if we take. At that point value 0. F dash of x equal to 0 means it is neither increasing nor decreasing. Next we will go to question number 4. So fourth and fifth, two questions at a time. I will write it here. Find the intervals in which the function f of x equal to 2x square minus 3x is increasing, decreasing. Next question number 5. Find the intervals in which the function f of x is given by 2x cube minus 3x square minus 36x plus 7 is increasing, decreasing. So we need to calculate in which interval the function is increasing, in which interval the function is decreasing. We need to find it, dear students. Question number 4. Find the intervals in which the function f of x is increasing. So first function you write, given function f of x equal to 2x square minus 3x, differentiate with respect to x, f dash of x equal to 2 into x square derivative 2x minus 3x derivative is 3. That is equal to 4x minus 3. So f dash of x value we got it. Now question number 1 in this. F of x is increasing. Then f dash of x is greater than 0. That implies 4x minus 3 is greater than 0. So 4x is greater than 3. That implies x is greater than 3 by 4. So on the real number line, this is minus infinity plus infinity. This is 3 by 4 here. X is greater than 3 by 4 means from here to here. Therefore, x belongs to 3 by 4 comma infinity, open interval 3. In this interval, the function is increasing. In this interval, f of x is increasing. Second one, decreasing in what interval? F of x is decreasing. Then f dash of x is less than 0. That implies 4x minus 3 is less than 0. So 4x is less than 3. That implies x is less than 3 by 4. X is less than 3 by 4. Here this is 3 by 4. Minus infinity plus infinity. So in this interval, the function is less than 0. X belongs to open minus infinity to 3 by 4. In this interval, f of x is decreasing. This is the way you can give the answer, dear students. Now come to question number 5. F of x equal to 2x cube minus 3x square. So f of x equal to 2x cube minus 3x square minus 36x plus 7. So to find the intervals of f of x, whether it is increasing or decreasing, you need to find f dash of x. So differentiate with respect to x, dear students. So f dash of x equal to, so 6x square minus 6x minus 36 and constant derivative is 0. So f dash of x is equal to 6 take common, x square minus x minus 6. Later we can find the factors 6 into x square minus 3x plus 2x minus 6. So 6 into, directly I am writing, dear students, x minus 3 into x plus 2. See, x square minus 3x plus 2x minus 6. So f dash of x value we got it here, students. So f dash of x equal to, are you able to see if I write like this? Okay, down you are not able to see. Till here only we can. Okay. Bye. Yeah, sorry for the disturbance, dear students. F dash of x equal to 6 into x minus 3 into x plus 2. So f of x is increasing. Then f dash of x is greater than 0. That implies that f dash of x value is what we got it, 6 into x minus 3 into x plus 2 is greater than 0. 6 bring this side, x plus 2 into x minus 3 is greater than 0. So x plus 2 can be written as x minus of minus 2 into x minus 3 greater than 0. Am I right? So when this is expression here, we have the formula x minus alpha into x minus beta is greater than 0. When alpha is less than beta, x is less than alpha or x is greater than beta. So based on that, x is less than minus 2 or x is greater than 3. So this is the real number line, minus infinity plus infinity. X is less than minus 2 plus 3. X is less than minus 2. X is greater than 3. Therefore x belongs to open minus infinity to minus 2, union 3 to infinity. In this interval the function f of x is increasing. In this interval f of x is increasing. F of x is decreasing. Then f dash of x is less than 0. That implies 6 into x minus 3 into x plus 2 is less than 0. That implies 6 bring the sign and x plus 2 can be written as x minus of minus 2. X minus 3 is less than 0. So x minus 2, again we have formula x minus alpha into x minus beta is less than 0. X value lies between alpha and beta. So here alpha is minus 2 and beta is 3. So x minus of minus 2, x minus alpha and x minus beta, x lies between minus 2 is less than x is less than 3. That implies x belongs to open to minus 2 comma 3. In this interval, f of x is decreasing. I hope everyone understands, students. Actually, I want to explain till the question of 6th, but unfortunately, because of some reasons, I am going to stop the session and I will continue in the tomorrow's class. Thank you all for your support. Jai Hind. Exam side mathematics by Pani. Thank you all. Because of some work is there, dear students, that's why I'm going to end the session.